Brooklyn 6G Summit 2025. We're at the NYU Tandon School of Engineering, and Anritsu has some demonstrations here, and Adnan Khan is going to tell us about what Anritsu is doing with 6G.
So wonderful. So we're doing quite a bit of stuff in 6G, but what we're showcasing over here are two main demos. One of the demonstration we have is joint communication and sensing.
We're hearing a lot of that today.
Absolutely right, and it has a lot of applications: drone detection, intruder detection, gesture detection. But the main advantage of the solution we're showing is the capability to be able to do monostatic, bistatic, multistatic sensing simultaneously.
Can you explain what you mean by those
Absolutely.
three statics?
Yes, I know. Well, so the monostatic is you have a transmitter and you have a co-located receiver. So basically you send the sensing signal, it bounces off the target and comes back. The other one is what we call bistatic, and bistatic is basically you have a transmitter, it's going to bounce off another target over there and go to a different receiver that is not co-located.
I see.
So that's between monostatic and bistatic.
Okay.
And multistatic is when we're combining them all together.
I see.
So we have got 4 different ports on the VNA. So that one of the key advantages is be able to do multiple statics, and the second advantage is we can test different waveforms. As you know, in 3GPP right now, they're talking about what frames are going to be used for, for sensing, for communication. Even though a lot of is being promoted to OFDMA. We're testing here with FMCW, which is radar. We're testing with multi-tones, with OFDMA and continuous wave. And then we can see what kind of pattern we're getting over here for looking at the power delay profile. So this is an example of the testing measurements we had done in an indoor lab. So we have our system over here. We have 1 transmit and we have 2 receives. We have a reflector over here. And then what we collect is pretty much looking at the different scattering as well as reflections across different, using M sequence, using OFDMA, using FMCW over here, in polarized and cross-polarized, monostatic and multistatic. So the key thing is to be able to do multiple waveforms and be able to do multiple configurations across a wide range of frequencies in the same environment without changing anything. So that's the plus point of it. So we have a lot of data that we have collected, and now it's up to the different bodies who are going to analyze and see how these reflect with the 3GPP models and make contributions to 3GPP.